You've just downloaded MATLAB and you're anxious to see what can MATLAB do for me. So let's go ahead and open the application, and you will see a GUI window similar to this here on the left. Okay, it might not look exactly the same. That's because you probably have a different version than I do. I have 2013A. But your GUI should be divided into 4 sections. The first section is the current folder. The second section is the command window. The third section is the workspace. And the fourth section is the command history. The command history is the least important window. If you do not have that window, don't worry too much about it. Let's start here in the current folder. So, going along with the current folder is the current path up here. This is our current path. So I've got my username Paul, and then I'm on the desktop, and then I've got a folder specifically for this course, MATLAB examples. Okay, that's my current folder that I'm in here. In my current folder is nothing. Okay, if I had anything in that folder, it would be listed right here in the current folder window. Okay. To show you that, let me create a new script. Okay, you don't know what a script is yet, that's okay. Let me save it as example. Okay. Notice the default location to save is your current directory. It asks, do I want to save that in MATLAB examples? Yes, I do, so I'll save that there. Okay. And I've got now this file example.m that goes into the current folder. So there it is. If I wanted to, I could double click and it would open, or I could click once and then a little bit later click again. I could rename it if I wanted to. It works the same way as your operating system works. Okay, there it is. We don't need this file for today, but there it is if we wanted it. Okay. Later on, this is important because it turns out that files can talk to one another. MATLAB files can talk to one another, but they have to be in the same directory to find one another, and it has to be your current working directory, okay, or else MATLAB can't find them. So make sure that you're in the current working directory and all your files are going in the same location. Okay, second, this is the command window, and you'll see that if you click there, you've got the little flashing vertical bar waiting for some text, okay, and you have this double greater than sign there. The double greater than sign is the command prompt. When you see that sign, it says that MATLAB is awaiting a command from you. So let's give it a command. Let's do 10 and use the asterisk there for times 5. It's 10 times 5. I'll hit enter. Okay, and it tells me the answer, 50. Okay, and then also notice then is another greater than, double greater than sign. So say, hey, I'm ready for another command. Okay, so I do 8 divided by 2, 4. That's very basic. MATLAB is a calculator. So I've got that there, and now let me start fresh, and I'll say a few words about starting fresh in a second. But I'm going to type CLC. Or I'm sorry, excuse me, I must type CLEAR, clear, and then CLC. Now, if I go to the workspace, there's nothing there. The workspace shows us which variables are currently stored in memory, in MATLAB's memory. Okay? Because we started fresh, we have no current variables there. We'll come back to that. And here's the command history. It shows exactly that, my most recent commands. Okay, here's clear, 8 divided by 2, 10 times 5, CLC, etc. Okay, so let's go back to the command window, and let's pick a variable name. Okay, you can pick almost anything, but there are some rules that you have to follow. I'll let you read about that in the textbook. But let's choose lowercase v. So our variable names are case sensitive. It's important that it's a lowercase v. So I'll say lowercase v equals, and let's just say 10, and I'll put a semicolon there. Okay, and before I hit enter, I'm going to explain this this command to you. What we're doing here is we're saying 10. We want to take the number 10 and assign it to a variable. And we're just picking that variable to be named v. Okay. The semicolon suppresses the echo, so to speak. When I hit enter, it again asks me for a new command. But if I were to say v equals 10 and leave off the semicolon, it echoes the value of v back to me and then asks me for a new command. So the semicolon suppresses that echo. If I have a new variable a equals 5, b equals 4, c equals 11, okay? Maybe I don't want all this stuff to junk up my command window, and I want to keep it clear. Okay? So then, in that case, I could add the semicolon to suppress those echoes. Notice, as I did this, the workspace filled up. Okay? These are the variables that are currently stored in memory. So if I scroll to the right, I've got v. V is currently 10. Okay? C is currently 11. So forth. It also tells me the minimum and the maximum. Variables can contain more than one number, and so this will tell us the maximum and the minimum. Okay. So because they're stored in memory, I can access them at any point. Let's say I want to access A. I can type A, hit enter. And it tells me, hey, that's 5. Okay. Well, watch what happens if I hit capital A. It says undefined variable a. And then it says, did you mean lowercase a? Oh yeah, I did. Okay. So again, it's case sensitive. So if I asked for uppercase a, as I did up here, MATLAB is going to tell me, hey, there's not an uppercase a stored in memory. Did you mean lowercase a? That's called a syntax error. Okay. A syntax error is an error in the commands, and that MATLAB can catch and tell us, okay, and repeat it back to us in a red error message. I can clear the command window by the command CLC. So if I hit enter, notice all those commands are gone in the in the command window, but those variables are still in the workspace. Okay, if I wanted to see what a is equal to, I can hit A, enter. It tells me a is 5 because it's still in memory. Okay, so CLC is just clearing the command window. If I wanted to clear the workspace or the memory, I can type clear and hit enter. And notice the workspace is now cleared. Now if I want to see what a is, I get undefined function or variable a again. That's because a is no longer in the workspace. It's no longer in memory. I've lost it. So let me clear the command window again. Now, in your math class, this statement, v equals 10, and 10 equals v, okay, I haven't hit enter yet, those two commands are the same. Right? In a math class, they'd be the same. In MATLAB, that's not true. And if I hit enter here, I get another syntax error. Okay, it says, the expression to the left of the equal sign is not a valid target for an assignment. Okay, when we want to assign a value to a variable, we have to put the value on the right side. Okay, that's the value 10. And then the variable in which that value gets stored on the left of the equal sign. So this is saying, hey, I want to store 10 into v. That's fine. Right? But if I say I want to store v into 10, and that doesn't make any sense because 10 is not a variable. 10 is a number. It's 10. I can't store something as 10. It's 10. So that's why MATLAB gives us this error. It says, hey, to the left of the equal sign, that's not valid target. You can't do that. That's another syntax error. Let me clear the command window, CLC. Let me clear the workspace. MATLAB at its most basic is a calculator. Okay, so if I want to do 10 times 5, I get 50. Okay, let's say I want to do 10 plus 2 times 3 minus 1. Okay, enter. 15. So what we learned from this example is that MATLAB also follows the order of operations. Okay, so it does the 2 times 3 first, which is 6, then goes left to right, 10 plus 6, 16, minus 1, answer 15. Okay, suppose we wanted to do the 10 plus 2 first, and then multiply that by 3. So just as you would in your calculator, you can put parentheses around that. 10 plus 2, close parentheses, times 3, minus 1, enter. 35. So here, MATLAB did the 10 plus 2 first, which is 12, times 3, 36, minus 1, which is 35. Also notice that in the workspace is this variable ANS. Where did that come from? You know, I didn't assign any variable called ANS. Okay, that's MATLAB's default. Okay, so it did a calculation here, and since I didn't store that calculation as anything, it stored it as ANS. And so if I want to get it back, I can type ANS because it's stored in memory. So I can hit ANS, enter. It gives me 35 again, right? Clear the workspace, clear the command window. ANS, 35. Okay. Notice now I'm going to clear the workspace. Clear. ANS is gone. Now if I hit ANS, sorry. Okay, I'm clearing the workspace. Clear the command window. If I wanted to store that calculation as a variable, let's call it C. Okay. I'll put a semicolon too. Maybe I'm not interested in looking at it. Okay. So I perform the calculation. I store it as C. Now in the workspace is variable C, and it's no longer ANS. Okay, so if I want to look at C, I can hit C, and it gives me a 35 now. Okay, so ANS is the default. Okay, let me clear the workspace. Let me clear the command window. Let's go to a slightly more complicated example. It's still not too bad, though. Not yet. Let's use the Pythagorean theorem to calculate the hypotenuse of a 3, 4, 5 right triangle. Okay. So let's say I have the first leg is 3. So there it is. And I put the semicolon again after it. Maybe I'm not interested in what first leg is. Okay. I don't want it to echo back to me, because I told MATLAB that it's 3. I don't need it to repeat it back to me. But if I did, you know, I could leave the semicolon off, or I could type first leg again and hit enter. It tells me, yep, first leg is 3. Okay, second leg, let's say that's 4. Hit enter. Okay. Again, it doesn't repeat it back to me because I put the semicolon. But it's stored in memory. There it is. Just to show you it's stored in memory, I can access it if I wanted to. Oh yeah, second leg is 4. Plus second leg, caret square, and I'll close the parentheses there. Okay, and I'll put a semicolon there. Maybe I'm not interested in having it echo back to me. So there's my command, and I'll hit enter. So, you know, what happened? Well, it didn't echo back because of the semicolon, but notice H is now in the workspace. So I look at H, and H is 5, as we would expect. Now I don't have to go to the workspace. I can have MATLAB echo it to me. I type H, enter, H is 5. Got it. Okay. Now suppose, let me clear all that. Let's say I did it again. First leg is equal to 3. second leg is equal to 4. And let's say I got the calculation wrong. Let's say I did the second leg squared minus the first leg squared. So I just kind of screwed up the formula. And hit enter. I do not get an error in this case. Okay, there's no error. There's no error because we didn't break the rules of MATLAB. MATLAB does not know what we intended to do. MATLAB just does what we tell it. Okay, as long as I'm following its rules. So now if I look at H, I get 2.6458. That's the wrong answer. That's not what I intended. Okay. This is an error of semantics. This is a semantics error. It's an error in the meaning or what I was intending. These are very difficult to catch. It's all on me to catch these because MATLAB doesn't know what I intended. Okay, it doesn't tell me in a red error message. So I have to go back and I have to look. Oh, what was the problem? Well, did I input the first leg correctly? Oh yeah, the first leg is 3. Did I input the second leg correctly? Oh yeah, the second leg is 4. Well, it must be in my definition of H. Oh yeah, I subtracted the 2 instead of adding the 2. Oh, there we go. H is 5 now. Now I've got it. I've fixed my semantics error. Okay, let me clear all that. Let me show you another use for the semicolon. First leg equals 3. Put a semicolon there. And then I can directly type second leg equals 4, semicolon. The semicolon not only suppresses the echo, but it allows us to put multiple commands on the same line. Hit enter. Notice when I hit enter, first leg and second leg both go into the workspace. Okay, let me clear that. I can use commas to separate commands as well. I'll say first leg equals 3, comma. Second leg equals 4, comma. Okay. The difference, though, is that the comma will echo back the commands to me. So I hit enter. First leg and second leg are populated in the workspace. Okay. But because I used commas and not semicolons to separate the commands, first leg and second leg are echoed back to me. Okay. I may or may not want that, okay, depending on the application. All right, I'm going to clear everything again. So that was CLC and clear. Okay. Now let's take a second example. Let's take a look at a second example. Suppose I have two variables. Swap 5 equals 1 and swap 1 equals 5. And I want to swap the contents of these two variables. That is to say that I want some commands after which swap 5 contains what swap 1 has, and swap 1 contains what swap 5 has. Okay. So at the end of my commands, I want swap 5 to equal 5, and I want swap 1 to equal 1. Okay. You might think that I could do that this way. Swap 1 equals swap 5. Okay, so I'm going to set swap 1 equal to whatever swap 5 is. I'm going to set swap 5 equal to whatever swap 1 is. Yeah, let me try that. That makes sense. We hit enter. Okay, I left the semicolon off, or I added the semicolon so it did not echo anything back to me. So if I want to see, well, what's in swap 1 right now? 1. Okay, that's good. That's what I was trying to do. What's in swap 5? Ooh, that's 1 as well. Okay, I wanted that to be a 5. This is a semantics error again, right? Because there's an error in what we intended to do. but we didn't break any of the language rules. So MATLAB computed it just fine. Okay? It's a semantics error. So we need to figure out where we went wrong. So let's do this a little slower. Let's clear everything. We said, okay, swap 5. We started with this guy. Swap 5 equals 1. Swap 1 equals 5. Okay? And I want to swap those two. Well, the next thing I did was I said swap 1 equals swap 5. Right? So now I'm going to do one command at a time, and I'm going to leave off the semicolon to investigate what happened. Okay? So that was one of my commands there. So let me hit enter. Okay, now swap 1 is 1. Remember, the assignment statement takes the value on the right, which is currently 1. Swap 5 is currently 1, and it assigns it to variable swap 1. So now swap 1 is 1. And then my second command was swap 5 equals swap 1. Again, let me leave off the semicolon, see what happens. Swap 5 is 1, it's not 5. Well, that makes sense, because after the first command, swap 1 is now 1. And so when we assign swap 1 to be swap 5, we're assigning again 1 to swap 5. So we lost the value 5 in all this. It was overwritten in this statement here. So how do I get around that? Well, let me start fresh again. Okay, so there are our values. Swap 5 is equal to 1. Swap 1 is equal to 5. What I can do is define a temporary variable. Call it temp. And I'll set it to whatever swap 1 is. Okay. And if I want to look at temp, there it is, it's 5. Now I will say, okay, let me set swap 1 to be whatever swap 5 is. Okay. If I want to look at swap 1, yes, now it contains that 1. That's because swap 5 is currently set to 1. So now we're saying 1 gets stored into swap 1. So now swap 1 is 1. And now, to complete the swap, let me say swap 5 is equal to, not swap 1, because swap 1 is 1 now. Now it's that temp variable. And if I want to look at swap 5, it's 5 now. Because on this statement here, temp is storing that 5, and it gets stored into swap 5. So now swap 5 is equal to 5. And we've completed the swap. Okay, so that fixed our semantics error. Okay. So, to summarize, let's go over the key points from this video again. Okay, the first is the MATLAB GUI has 4 sections. And you have to place all of your files in the working directory in order for MATLAB to find them, and in order for your files to talk to one another. This will be important later on. Okay? Today, we don't need a file. We're just investigating the command window. MATLAB works as a calculator. Okay, at bare minimum. At its bare minimum, it works as a calculator. It follows the order of operations. including those parentheses that we used. Okay, we can use the function, the command CLC. Okay, CLC clears the command window, and we can use the command clear, which clears the workspace. The left and right of an equal sign are not the same. Not the same. The left is the variable in which we are assigning a value. The right is the value, and you cannot switch those two. Okay. We saw two uses for the semicolons. The first is to suppress the echo. Okay, if we don't want MATLAB to echo back to us the command, we add a semicolon. The second was to separate more than one commands on the same line. And a comma also separates more than one command on the same line, but a comma will echo the values back to us, or echo the commands back to us. We talked about syntax and semantics errors. A syntax error is a break in the rules of MATLAB's language. Okay, and MATLAB tells you that you're breaking its rules with a red error message. Okay? Thus, these are easy to correct because MATLAB tells you error, and it's pretty descriptive in what the error is. Semantics errors are errors in the meanings of statements. Okay, what did you intend to do? Okay. These are harder to catch because MATLAB doesn't tell you about them. It does not know what you intended to do. If you're getting the wrong answer, but your code runs or your commands go through, then you've got an error of semantics, and you have to figure out where that error is happening and fix it. Okay, finally, we saw that the variable ANS is the default variable. Okay? If you perform some sort of calculation, okay, and you don't set it equal to anything, MATLAB by default sets it equal to the variable ANS, and you can call ANS up if you want to see what the answer is.